Okay, well, good evening, everyone, and I'm delighted to welcome you all to this year's joint Royal Academy of Engineering East Midlands regional event and the University of Leicester's annual engineering lecture. It's wonderful to see such a distinguished audience today, including fellows of the Royal Academy of Engineering, senior representatives of the Academy, and our valued partners from universities and industries from across the East Midlands. And I think your presence really reflects the strong collaborative spirit that exists across our region and within our region. And so we're really pleased to see so many attendees here today. And today's lecture is particularly timely, focusing on a topic that really sits at the heart of the future of higher education and indeed probably of our future lives. So AI-powered universities. We're honoured to have Professor Nick Jennings, CB, FREng, FRS, and Vice-Chancellor and President of Loughborough University, but also the newly elected Vice President of the Royal Academy of Engineering, as our keynote speaker today. Professor Jennings is a leading authority on artificial intelligence, autonomous systems, and cybersecurity. And we're really eager to hear his insights into how AI is poised to revolutionise the way we conduct our research, how we educate our students, and also how we manage our institutions. The University of Leicester and Loughborough University are on very ambitious journeys of digital transformation through our digital strategies, through our digital master plans. And these strategies are not only about implementing new technologies, but also about reshaping the entire academic and operational landscape that will enhance the experiences of our students and also of our staff. As neighbouring universities, we share a commitment to harnessing the innovative and modern solutions that drive progress and also uphold our reputations as leading institutions of higher education in the East Midlands. Tonight's lecture will explore how AI can power our universities, and it will also offer a glimpse into the future where digital technology not only supports, but actually propels our academic missions. Now, please join me in welcoming Professor Nick Jennings.
Thank you. Before I start on talking about AI-powered universities, I thought I would just say a bit about the Royal Academy of Engineering for individuals in the audience who may be less familiar with this. I assume many of you are familiar with the University of Leicester and the school and you are in, but I wanted to say a bit more about the Academy. So as Sarah said, I'm recently announced as the Vice President for Fellowship Engagement. There are two Vice Presidents at the Academy. So the Academy is three things, and these are all important and distinctive offerings of facets of the Academy. Firstly and foremost, it is a charity, so delivering public benefit from engineering excellence and technology innovation. So that's what it is in terms of its statute. It is also a national academy, so it's the National Academy of Engineering, that aims to provide progressive leadership for engineering and technology and independent expert advice to government in the UK and beyond. So it serves a function as a national academy alongside our other national academies that we have in the UK. And it's also a fellowship, bringing together a community of leading business people, entrepreneurs, innovators, government advisors and academics from every part of engineering and technology. So it has each of those facets as an important part of what it is as the academy. The overarching vision is to use the power of engineering to build a sustainable society and an inclusive economy that works for everyone. So that's what the Academy seeks to do. And in particular, there are three main things through which it delivers that. So firstly is policy and engagement. So policy, working with governments, both nationally and regionally to help set important policies. So I used to chair the policy committee at the Academy, and during COVID, for example, we gave lots of advice to government on things like indoor air quality and social distancing and how you could operate, things that you would expect engineers to be able to help government with. So sort of that's the policy piece, and engagement is more broadly, so talking publicly and in public fora about engineering, about the benefits of engineering, what it's like to be an engineer and those kind of things. So sort of policy and engagement. Second is around talent and diversity. So there are a number of schemes that the Academy runs that aim to grow and attract the best talent into engineering, and when in engineering, to develop engineers in their careers. And so the Academy will run things like fellowship schemes, it will have research grants, and those kind of things to actively develop it. An example of working on diversity is the Academy has set up a number of funded places for MScs for black students in aero and automotive engineering, jointly with Sir Lewis Hamilton as part of that broader commission. So really trying to get more black students into motor racing and Formula One. So that's an example of an intervention in terms of diversity. And then in terms of supporting innovation, the Academy has an enterprise hub, supports entrepreneurs to develop their businesses and to be able to really take benefit from operating in the Academy. We are just entering a new phase. So phases in the Academy are slightly defined by the president at the time. Presidents get 5-year cycles. So we have just finished Sir Jim MacDonald from Strathclyde University's principal as our president. And so our new president is John Lazar, who's a global tech pioneer and investor and is also chair of the Raspberry Pi Foundation. So we're just in the process of working out what the next 5-year strategy for the Academy is going to be. And in fact, a number of fellows met here this afternoon to have that discussion. So I wanted just to say a bit about the Royal Academy of Engineering, since this is also a Royal Academy of Engineering lecture. So I'm going to talk now on the main substance of what I said I would, which is AI-powered universities. So AI is a very important and timely topic to be talking about. You might have seen the Nobel Prizes that were awarded this week for a number of AI researchers. I think they didn't have my mobile phone number, so I didn't quite get the call, but you never know, maybe in some other discipline. So AI attracts some bold statements. People have some quite strong views about it. So AI will have a more profound impact on humanity than fire, electricity, and the internet. I think that's quite a bold claim to what it might do. To the other end of the extreme, so development of full AI could spell the end of the human race. So they're quite a broad set of possibilities of views of what people think AI is. AI is also in the press on a very regular basis. I would say sort of, here's a sample of some of the headlines. I would say a lot of them, killer computers taking all our jobs, taking over the world, are sort of some of the more, headline-grabbing statements that people make about this discipline. So it's a topic of broad interest. So the fact we have a broad audience here is great. People have quite divergent views on what it is and what impact it's going to have on society. And I'm going to try and talk about some of those things. And I'm going to couch it in the context of universities. I've spent most of my professional life in a university. I now happen to run a university. And so bringing together sort of AI and what I know about universities seemed like a good way to structure a lecture. So just some basics, first of all. So AI, there are many, many definitions of AI, and sort of, it's a complex thing to to pin down, because in essence you have to try and define what you mean by intelligence. I think the artificial bit of AI is kind of reasonably obvious for most folk. Trying to pin down what do we mean by intelligence is a slightly more complex thing. Here's a very standard definition from an AI textbook. There are many other definitions. I think my feel is you get the feeling for what it is. It's about constructing programs that will behave in a smart way. So here it talks about able to function in a particular manner with some foresights and not just responding to what's going on. Historically, and by historically I mean probably for most of AI's existence. So AI came into existence as a discipline, as a phrase in the mid-1950s, as a phrase when people started talking about it. So for most of it, up until probably the last 5 to 10 years ago, most of the focus has been on building AI systems to do a specific task. Be that medical image interpretation or production line optimization or whatever. So you build an AI system for the particular task that you want it for. And that's where AI has been for most of its history. Recently, there has been there's been a focus due to some impressive technical developments on more general purpose AI. So by more general purpose, I mean AI that does things beyond the one task for which it has been designed. So you might have come across, you might even have used things like ChatGPT, Claude 3, Gemini Ultra. These are all examples of broader-based AI systems that you can try a whole load of things in. It just doesn't commit itself to just one task. And so these kind of systems are very impressive. If someone had showed me 30 years ago when I started doing my PhD in AI that someone had shown me ChatGPT, I think that's it. That's what I mean. That's what I want to build in terms of AI. And it's interesting now we've got there, you think, maybe that's not quite what I meant, but we'll come to that. So, these AI systems can engage in reasonable multi-turn conversations. They can write short computer programs. They can translate between multiple languages. They can summarize long documents, and they can do those reasonably well with some caveats that I might come into. So that's what I mean, and that's what I'm talking about when I speak about AI. AI is not some distant thing in the future. You will have all interacted with an AI system probably today, certainly this week for most people. A lot of it's hidden, so you might have used ChatGPT, in which it's reasonably obvious then that you've used it. But if you've used things that make recommendations to you, you've seen this film, you might like this other film, or you bought this book, you might like this other book. That's a simple example of an AI system. When you use on your mobile devices, you might have face recognition in order to get into it. That's a classic AI problem. The scheduling and the organization of things like Uber and other sort of on-demand devices, they're all about using AI in order to do that scheduling, that optimization piece. So it is routinely out there. Sometimes you're conscious you've used it, sometimes it's maybe less apparent. So AI has been around for a decent amount of time. I've spent all of my professional career being interested and researching in AI, and I would say in that time, it's been a rocky journey. At various points, I've had people genuinely have the conversation with me, why are you wasting your career on this failed technology? It will never get anywhere, and it was difficult to get funding, it was difficult to get students, it was difficult to get interest. Where we are now is quite a different place from that. We've probably had a couple of those cycles throughout my career. So why is it popular now, and why is there such broad interest? So that's what the again part of that is. So AI is popular because actually at the moment, in terms of what it does, it can do a whole load of reasonably impressive things. And in some cases, it can do things considerably better than humans can. Even humans who are very well qualified in highly skilled jobs for things that we send people to university in order to do. So that's why it's popular. This success and effectiveness is driven by three main things. It is driven by the availability of massive training data sets. So it is estimated that the latest version of ChatGPT is trained on 3 trillion tokens. So think of that as words or sentences, 3 trillion of them. When I started my PhD, I had people in the lab working alongside me who did machine learning, and if they had 100 items in their data set, they were quite happy. That was quite a large data set. Imagine, like many things in life, if you've got 100 examples of stuff and you've got 3 trillion examples of stuff, you're in general going to do better if you've got 3 trillion than if you've got 100. So sort of that data set availability is a really important aspect. Secondly is processing speed ups. So we just have much more capable computers now. And when you've got much more data to crunch through, then that ability to run things in a particular time is a really important aspect. And then the third things, and these are in order, in my view, of importance. So I think data is the most important thing. I think speed ups are the next. And the third is new algorithms. There are new algorithms around, but many of the algorithms or many of the bases for the algorithms that underpin ChatGPT have been around for a long time. They've been around for many years. There have been improvements in them, but my contention would be that actually data and processing is the thing that's really driven it. I'm going to I have the hypothesis, and I'm going to try and convince you of it at some point during this talk, is that humans alone can't process the volumes of data that are necessary to make informed decisions in today's modern environment. And so what we need assistance in making sense of the many opportunities and the many data that we have in front of us. And I think this is true across all information-rich domains, which I think is basically all domains. So I think those are the reasons why AI is so popular again. So that's the sort of foundations. That's why I think AI is. That's why I think AI is important. That's why I think you should be interested in it. Let's talk about it in terms of a university context, which will be familiar to many of you within this room. So I strongly believe that AI will power our universities, hence the title of the talk, transforming the way we undertake research, the way we educate our students, and the way we run our institutions. So I think AI will have a profound effect on what we do. And I want to talk through each of those things. So let me talk about educating students first of all. So I've tried to pick a couple of examples of where AI will be used under each of those different domains. There are many others. I'm not saying these are the only ones. So AI has always been connected to education, and there's always been a strong belief or a strong hope, I would say, in early AI, that AI offers us a way of personalizing our learning to every student. So we all know that we all learn differently. We all learn at different rates. We all learn in different styles. And that ability to be able to make that pedagogical way of interaction and way of working, I think AI gives us a way in order to do that. So you can think of this as actually, rather than sort of standing at the front of a class or engaging with the class en masse, being able to tailor individual pieces to individual students and what they know. So really to be able to follow an individual's progress, to present content and assignments that are really tailored to them, to their learning style and their ability, because of the ability to be able to track and have the data on this. The hopeful bit for those of us who are academics in the room and think education is really important, is that I absolutely do not believe that humans are going to be taken out of that loop. I think AI can enhance what humans do, and I think human educators are really, really important in that piece, to provide that sort of piece of humanity, that bit of understanding, and that bit of interpretation, and that bit of guidance. So I think you can get something from AI, and I think you can get a decent amount from that interaction with an AI system, but I think there will always be a need for high quality education to be supplemented by human educators. ChatGPT has driven a lot of discussion and a lot of thought in academic circles, I would say. And it was really interesting when it first came out. A whole load of universities said, we are banning ChatGPT. We're going to stop our students using it. That's a ridiculous proposition as far as I'm concerned. I think, A, it's not possible to do that, because actually it's not always easy to figure out what is student generated, what is ChatGPT generated, and nor does it reflect the reality of being able to use a powerful tool. Why wouldn't you want to be able to have AI systems? It's like saying, I want you to write an essay, but I don't want you to use the internet. You're not allowed to use Google or any other search engine. It's not a plausible way to go. I think you want to be able to make the most of those things. You want to be able to work with an AI system, because it will improve education if you get it right. So banning them is a ridiculous idea. Figuring out what authentic assessments are that you can't just outsource to ChatGPT is a really interesting area. And sort of, in a doomsday-like scenario, you have students putting their questions into ChatGPT to get your answers. You have assessors using ChatGPT to mark the assessments that come in, and sort of you've got machines marking machines, and actually no human involvement in any of those things. And that's clearly quite a dystopian world. I feel that's not where we should be aiming to, and that's the importance of making sure that assignments and assessments, so you can still genuinely test learning. So really thinking and having a strong idea about how we can use AI systems to help generate ideas, to help augment ideas, to really be able to flesh things out. How you can use it to explain difficult concepts is really useful. I spent time in government as a chief scientific advisor, and I had to advise across all sciences, right? So if it was a computer science question, I was on moderately good ground, but in the breadth of things I had to look at, there were a whole load of disciplines that I didn't know a great deal about or had experience in. And how do you learn about them? Ideally, you go and find a friend who knows about these things, but otherwise you interact with Google in order to figure out, actually having something like ChatGPT that you can have a dialogue with. You can say, ask it and say, I don't quite understand this bit. That bit is a really powerful and really useful way to go. So in terms of concept explanation, and also in terms of how they can enhance written material. So I recently wrote a blog called AI-Powered Universities. It was in the Times Higher, and it's on my webpage at Loughborough. And so I wrote the blog, and then I thought, well, this is an AI blog. What happens if I put this title into ChatGPT, and what will it give back? And so I did that, and it came back with a decent blog. I thought mine was better, but only just. But there were bits in there that ChatGPT had put in its blog. So I said, write me 1,500 words on AI-powered universities. And there was an angle in there that it had that put in that I hadn't thought about actually. And so what I did is I took that, I obviously didn't cut and paste for students in the room, rephrased in terms that I understood and connected it to the rest of the document in order to be able to do that. So chatbots I think are really interesting. Also as educators, really the ability to really have that real-time course feedback in terms of what we want to be able to do and understand. So, as educators, we try to engage people, we try to understand what they're learning, and how do you find out what that's actually going in? That the lectures you've spent doing, how do you know that a student has actually understood anything you're talking about? So you can do assessments and you can do exams at the end of the year, the end of the term or the end of the year, but it's a bit late by then. What you really want to be able to do is to have much more interactive ways of figuring out what folk don't understand from your lectures, or what they do understand and what they really are interested in. And so through making it much more interactive, you can really identify those kind of misunderstandings much earlier on, almost in the lecture as you're giving them. And also gives you a way of getting feedback from the quiet majority. I would say as academics, it's easy to get feedback from the students who are always very keen and always ask lots of questions, but that's a small percentage, or maybe that's just my lectures, where that happens. You don't hear from most students, and actually that ability to really understand what the whole cohort understands is a really important thing. I'm just going to do a quick plug for some of the things we've got going at Loughborough. I'm not doing too much Loughborough, it's meant to be AI in general. So we've just done a significant investment in something called DigiLabs, where we're using digital technologies to really see how we can enhance our education and student experience. And we've developed, we've got a whole load of equipment and kit and capabilities now that we didn't used to have, and we're now that make it much easier to analyze data, to visualize data, to use augmented and virtual reality and robots, and AI is an important part of that. And we're in the process of figuring out how we can really make sure that the education that we offer our students is really up to date and modern. And I'm sure you have exactly the same, similar sorts of things here at Leicester and other universities represented in the room. So that's education. Let me talk about research now. So AI and research. So AI opens up whole new areas of research, as in areas of research that we didn't used to do. So a couple of examples here. So rights of sentient machines. So there's now there's quite a few people who would research in that broad area. So a sentient machine, what rights does it have? What at many different levels. So that's a topic that 20 years ago didn't really exist because it wasn't really a thing. We didn't really have sentient machines, and what their rights were not often considered. Computational creativity. So what does it mean for computational creativity? What does that mean? How can we use computation to improve our creativity? So the picture there is an example of a painting. It's a generative AI painting. That was recently sold for about £300,000. You think, that's a program I'd run moderately often if I could get £300,000 from every output that I produced. But then there is a bit about supply and demand, I guess. So sort of, AI really being used for things that we would consider creative, art, music, culture, poems, all of those things. What's the role in those? So that's whole new areas of research. Where it's being used most, as in most frequently, is in new ways of doing research. So areas like computational drug discovery, protein structures. So Demis Hassabis and colleagues have just won the Nobel Prize in Chemistry for an AI program, AlphaFold, that predicts 3D protein structures. So that's an example that was deemed to be an open problem. So it's been open in the literature for decades now, thought to be decades away from being solved, but they solved it through AlphaFold. And now that ability to predict 3D structures is being used all around the world. So it's being used by literally millions of researchers in order to help them speed up their analysis of what proteins can do and what structures they will have and what behaviors will exist as a consequence. I want to say this to all colleagues. I think AI is going to impact all academic disciplines. So not just those in STEM subjects, all academic disciplines. And I think if you're in a discipline and you are not thinking what AI is going to do for your discipline, someone else in your discipline will be thinking that, and that will give them an advantage. So I genuinely believe that it will impact in some way all disciplines, not just the STEM-related ones. Again, I'm going to just briefly sort of pick out a couple of examples of where it's being used in research. We've got examples from all of our departments in Loughborough. I'm able to find someone somewhere is doing research in AI. I'm sure that's the same at other universities as well. So, some of the things that we're using for in climate change and net zero, one of our strategic priorities, precision agriculture, so that we can make crops much more productive and sort of deal with food supply chains, sandwiches, making sandwiches, and then reinforced concrete as well. So being able to monitor and track what's the state of concrete building. So they're just some examples. As I say, these are I could have picked many others, and you will have many others at your universities as well. In terms of vibrant and inclusive communities, a second key priority for Loughborough, again, sort of seeing how we can use AI to help those who are disadvantaged, so with learning disabilities, or from underrepresented groups, how you can analyse and take data from those. Again, being able to do things that sort of weren't always available to those groups. And then our third sort of strategic priority is around sport, health and well-being. So how you can use AI to help in health and well-being, I think most people can get a feeling for. Some of the things that we use it for in terms of sport is in terms of talent identification. So how can you work out who's going to be a good footballer or good cricketer or good American footballer? Pick your favourite sport out of those. So how you can use AI to predict those. I'm a massive cricket fan, and so one of my favourites is a spin out that we've got that will help people who bowl at cricket. So how they can improve their bowling action so that they are less likely to get injured. And this is an example of where I think AI can help democratize things that if you're really at the top end, you can get for yourself. So one of the things that we did at Loughborough was we rebuilt Jimmy Anderson, who's England's leading wicket taker's bowling action. He used to get injured a lot and at the beginning of his career. And then he went through a remodeling of his action in order to make him not get injured. That made him way less effective as a bowler because he stopped swinging the ball at that point. And so we had to rebuild it. And we were able to do that by having a very elaborate lab with lots of sensors and really rigging him up. And that was fine if you're Jimmy Anderson and you're one of the world's best cricketers. But if you're a club cricketer, you don't have access to that. So how can you do that through taking a video on a mobile phone? So that's what the spin out does. So as I said, really impacting research across a whole range of different areas. I want to sort of give a slightly personal perspective now on terms of AI and research. So I think AI, and here, think about ChatGPT, is overly focused on disembodied intelligence. So by that I mean sort of a computer program that's not connected to the world. It hasn't got sensors and it hasn't got actuators. So ChatGPT, you type a query into it, it does some stuff and you get an answer out of it. I think that's part of the solution, but I think that's only a narrow set of AI types of system. I've always been interested, and that's a copy of my PhD that I published as a book when I wrote it, in systems where the AI system has sensors connected to it. So it can receive information from the world and it can make some actions that change the world. And so that gives you the notion of an AI system as what I call an agent here. So something that acts, has a purpose and does stuff. ChatGPT, if you don't log on and type it in, it does nothing, right? It waits, it's purely reactive. It responds to what you type into it. I think there's a whole variety of much more useful systems that will be active all of the time. And as soon as you think of an AI system as an agent, as something that's got a particular aim that it's trying to achieve, you automatically think about, well, if there's one of them, there's going to be a whole load of them, right? So there's not just going to be one agent. We are not all going to use ChatGPT at the same time. We're all going to have our own agents. In fact, we may have multiple agents. And as soon as we've got multiple agents, they need to interact with one another. And they might cooperate, and they might compete, and they might coordinate, but they will definitely interact with one another. And not only will they interact with one another, they'll also interact with humans in order to do that. So I think the next wave of AI is very much going to be around agent systems and around multi-agent systems that interact with one another. Now, this is a prediction I've been making for 30 years. So at some point, I'm hoping I'm going to be right. I think we've focused a lot on individual intelligence. The multi-agent perspective will come in due course. And this gives way, I think, to how a dominant way that I see AI systems coming into practice. And that's with humans and AI working together in partnership, so working together to get things done. Noting that machines are good at particular things, at particular types of characteristics. Humans are also good at a different set of things. And that if you can get that right, if you can get that balance right, and if you get that interplay right between them, then you can really have something truly powerful that makes the most of the humans and also makes the most of the machines. And that notion of partnership, I think, is really important. The final bit, so AI-powered universities. So I've spoken about what AI might do for our education. I've spoken what AI might do for our research. What does it do in terms of running institutions? You may be pleased to know, and you might also be pleased to know, Nishan, that I don't think an AI could be a Vice-Chancellor, thankfully. Many of your staff and colleagues might think actually an AI system might be a whole lot better than our current Vice-Chancellor, but that's a discussion to be had. So AI and running universities. AI will automatically come into university land because we are modern. I'm going to say this without laughing too much. We are modern digital organizations. So we have a lot of data and we want to be able to do things with it and to be able to combine it in different ways. So AI that's being used in HR and finance, in marketing, will automatically, we'll get, because all the companies who supply us those things will be doing that. But thinking really beyond that, how it can be used in things that are a bit more specific to us as institutions. So I think the idea of a student assistant, so someone who will help students figure out what they want to do. So again, knowing what they know, knowing how they like to learn, knowing the things that they're interested in through interactions with them, really tailoring what options get taken, what courses to do, what extracurricular activities are happening in and around campus, keeping an eye on health and well-being. Really important, that sort of using AI for good. For staff, imagine we had some AI systems that could help with that routine admin, that meeting scheduling, those expense claim forms, all of that sort of routine admin business that we all spend too much time doing. Imagine we could automate some of those things. Imagine we could use it to help determine feedback from surveys that we take. Imagine we could use it to keep track of who we should be collaborating with and who we should be partnering with. And so to wrap up, AI is a really important topic, but it's far from a done deal. There are lots of challenges, lots of things that still need to be done in AI. So if I actually had time to research in AI still, there would be plenty to keep me going for the rest of my career. For younger researchers in the room, there's plenty of AI challenges that will keep you going for the whole of your careers. It's far from being a done deal. So things things like, I spoke about multi-agent systems, how AI can learn to interact and be a good partner for us. AI systems and computer systems in general are rubbish at being partners. We have to adapt to how the computer system is designed, how it works, how it operates. That's not what we want to be able to do. We want the machine to know what it's like to be a good team player, to cooperate with us, to be able to engage with us. And so there's a whole load of areas associated with that. So final slide, what I've tried to tell you. So AI lets us do new things. And I genuinely believe that many of these will be good for society. AI is a powerful general purpose technology. Bad people will use it for bad things as well. And that's the balance that there is. So because it's so powerful, bad people will use it for bad stuff. And that includes frauds and scams, disinformation, offensive cyber, those kind of things. AI is being used and will continue to be used for all of those things. I think AI is essential for many complex problems. It's got a wide range of impressive applications. Almost on a daily basis, you see the latest AI programmed to do something particularly impressive. The breadth of system capabilities continues to expand, but there are many challenges remaining. And I want you to leave with the message that I think we should think of AI systems as partners. So an AI system that recognizes and works with us, so recognizing our complementary expertise and roles. And if we get that right, that's good for the people, and that will make the machines more powerful. Thank you very much.
Thank you very much for such a thought-provoking and insightful lecture. I think your vision of AI-powered universities has given us plenty to reflect on. And I think one of my reflections is really we're looking at a time of incredible speed in innovation, in research, in education and managing our institutions, and it's how we harness that. I know we're on a tight schedule, but I know you're willing to take some questions.
Absolutely, yeah.
So if anyone has a question, there is a roving microphone and it'll be brought to you. And if you could start by saying your name and organisation before asking your question, that would be fantastic. So I can already see some hands. So if I could go straight to the back.
Thank you, Professor Jennings. I'm Dr. Wen Wang from School of Business. Mm-hmm. I sort of disagree with your your comments on student learning will be led by AI, supplemented by human being. Mm-hmm. I thought it should be opposite, because AI kind of plays a teaching assistant role to impart knowledge, but as lecturer, to inspire and to guide, to help students to problematizing the issues. I don't think it can be replaced by AI. So I would like to hear your comments.
So maybe I wasn't clear enough in that piece. So I think I tried to make exactly that point, is that AI will not replace us all wholesale in general in our education model. I think there are things that humans are uniquely good at in terms of engaging other humans, and the AI will be part of that, but it will not be a replacement for it. So as I tried to say, I think sort of human educators will always be part of high quality education.
Thank you. I thought AI is good at imparting knowledge, but to demonstrate the joy of work and curiosity, it's human will be better.
I completely agree with you.
Thank you.
Okay, I'll go there, and then I think there's a question further down as well. So, person with the blue shirt.
I'm David Bartram. I'm a sociologist here at Leicester.
Hi.
Is there nothing to say about potential costs, drawbacks, risks, etc., especially in connection with education and research?
So yes. So I've tried to sort of paint a view that sort of I'm generally technically optimistic about what AI will do for society, but there will be downsides. It's a general purpose, powerful technology, and I think we need to have a debate as a society about what we are willing to what's acceptable to us in terms of reasonable use of AI. That often manifests itself in terms of discussions about jobs and sort of meaningful jobs and meaningful job creation. I think AI will change jobs. I think it will change a number of jobs. I don't see the wholesale mass unemployment and none of us having jobs and all of us being on the beach, which might be a utopia for some, but sort of I don't think is where we will end up as a society, which is where I think the human AI partnership bit is a really important angle. So I think of AI as a friend and an augmenter to those things, but you're absolutely right, there are potential downsides. We need to make sure that those are properly taken into consideration. And that's kind of the, that piece on the AI is going to wipe us off the face of the earth. AI is going to take us over all those jobs. I think there are elements of those positioning that are really important that we discuss as a society. I don't believe the extremes will happen though.
Thank you. So I think I saw Ashik's hand go up, and then I'll come here. Yeah, I need to look at that side as well.
Yep.
Yeah.
So Ashik, I'm computer science, Leicester.
Hi.
So we could compare the uptake of AI to mathematics, what was 100 years back. So 100 years back, almost all discoveries were enabled by mathematics, either it's physics or biology or engineering. Then other disciplines consumed mathematics to an extent that the mathematics itself started shrinking, and we had a recruitment crisis, probably in mathematics departments. Mm-hmm. So what's your prediction that similar trend would happen, that computer science would become, or AI would become to some extent enabling subjects, that physicists, biologists, sociologists, mm-hmm. or psychologists would have sufficient understanding that they would become experts in AI, and the computer science department would have a recruitment crisis, and we would start looking into something else, actually.
Ask as a slightly interested person in that, I'm guessing. So my thoughts are AI will pervade almost all academic disciplines, and that's the example I tried to give. I think it's important that particularly at the moment, to get the most of it, you need to know a bit about AI, and in particular, you need to know a bit about what it can't do or what is a bad idea for it to be able to tackle in order to use it. And I think that bit is important. So sometimes I worry that there's not always sort of quite enough experience in terms of using some of these very powerful techniques and technologies. So I think that's really important. I think it's one of the joys of having been an AI researcher, I would say, is that I've worked with a whole range of different applications. And when I'll do a public lecture on AI, I will challenge the audience to think of a topic, think of a discipline that will not be impacted by AI, and I will endeavour to try and find the answer. So there are possibilities across a whole range of spectrum, and that's fantastic. As a computer scientist, that really excites me and is something I've really enjoyed. In the same way that mathematics is often used in that way. So I'm optimistic about it. I think one of the things we need to be careful as computer science academics is that we still have computer science academics who still exist in computer science department and don't go all off to the big companies in terms of opportunities. I felt that a lot, particularly when I was at Imperial, in central London. Lots of AI companies at the beginning just took out lots of our academic staff, because that's where a lot of the AI expertise came from, is from our universities. And so sort of getting that right is companies can't just take everyone, because then there's no one left for the next generation. So you're all right. You're going to be fine.
If I could just take a question from over the far side. I think you had your hand up. Yes, over the far side there, and then I'll come back to the middle.
Hi, thanks for that. Kate Cliff from the University of Leicester. I just wanted to ask whether you felt that there were any inherent biases within AI which may threaten kind of healthy EDI cultures inside of universities.
So it's one of the things in AI, and actually I'll make this point now. So bias in AI systems is absolutely something that you should worry about. It's trained on all the things that are out there, and there are lots of examples of kind of chatbots that have been trained or led astray by people and have exhibited some very inappropriate and very biased behaviour. And so you have to engineer your system well in order to think about that. But bias is a great example where we should worry about bias in all of our algorithms, any software system, whether it's got AI inside it or whether it's not got AI inside it. Bias is absolutely an issue in it. And so this is my AI exceptionalism bit. Sometimes things get labelled to AI like bias and fairness and those things. And you think, that's true, yep, it should apply to AI, but it should apply to any software system. And so you should worry about algorithmic bias and algorithmic fairness rather than AI bias and AI fairness. So it's absolutely a problem. There's starting to be a number of research methods now where if you look at the training of an AI system and the training of its data, it can start to try and identify where it has gaps and where it may have biases. And I think that's the way to do that, because I think trying to do it as a human is an implausible thing to do. There's a paper recently published that said there are 47 different versions of fairness in the literature, and they are mutually incompatible. Nothing would satisfy all 47. So it's important to understand what it means, and it's important to understand what it means in your context.
Okay. I think there's a question. We're patiently waiting here.
Thank you. My name is Frederick Wheel. I'm from Multiverse. A bit of a prepared question, but I promise I didn't use AI for this.
Yeah.
So we interviewed over 1,500 tech leaders and their employees across the UK and the US to assess their experiences, challenges, but also future plans when it comes to AI. More than 90% of those interviewed said that the benefits of AI have either met or exceeded their expectations, but with some drawbacks like increased investment into technology, but also upskilling their people in knowing how to use it. We just talked about beware of AI exceptionalism. How do you foresee the higher education sector overcoming this challenge, but also in the light of the funding crisis currently grappling the sector?
Thank you. That's a really interesting question. So I think being really clear about what your AI system is going to do and its limits is really important to do. So I will often meet chief execs or government ministers or the like who will say, we have this really difficult, intractable problem that we've had for 20 years. I'm going to magically sprinkle a bit of machine learning or AI over this system, and lo and behold, all my problems are going to disappear. And if you analyse it, there's a whole load of statements from chief execs and, as I say, politicians who think that will not happen. And if you're going to think you're just going to sprinkle a bit of AI on and all your problems, long-held problems, are going to disappear, you're in for a bit of a shock. I think a lot of AI system developments for companies and organisations about making sure you've got your data right, making sure that you've got all of those basic underpinning dull things really in place, and then you can build some AI on top of it. So it is expensive unless you've got a really good data infrastructure, which most organisations and most universities don't have. So there will be costs, but there will also be those benefits that you hope you'll be able to take on top of it. It's challenging in a difficult funding environment, but I think we don't really have a choice. I think in terms of what our students expect and what our staff expect, I think it's really important that we are able to be that modern digital organisation.
I'll take a couple more questions. There are a couple of hands. I think Simon, and then here. So Simon, do you want to? Yeah, the microphone.
Hi, Simon Gill,
Hi, Simon.
Dean of Research in the College of Science and Engineering at Leicester. I liked your quote from Stephen Hawking at the start because it brought back memories, because I used to work for him and I had that conversation with him in 1994 in the Randolph Hotel in Oxford. I remember it well because his favourite tipple was a bottle of Chateau Neuf du Pape, but his speech synthesizer could only say Newcastle of Pope. So, so we had an argument where I argued that the capabilities of AI would be limited fundamentally in the end by human intelligence, and he disagreed. Do you agree with me or Stephen Hawking?
Thank you. That feels like something of a difficult choice to make. I think, and the tones of, and what I've tried to convey is, I think there will always be things that humans are better at than machines. And figuring out what that set is a really interesting research challenge. And I think we see some bits and we see some glimpses of it. I think many of us feel that sort of the emotional engagement attachment piece is much better done by humans than a machine. But then you look at some of the things that go on with robotic pets and sort of assistants in other parts of the world, and you start to wonder whether, in fact, that is still true. So, but I'm optimistic. I think there are things that we will be able to do that machines will not be as good at us as doing. So I think there will be those limitations. I don't think we're going to be wiped off the face of this earth by super intelligent machines.
So I was right then. Good.
Unfortunately, you can't go and carry on your argument with him anymore.
I think there's a question there, and then I'll probably give the last question to Himanshu.
Jim Wickerson, Rolls-Royce. You mentioned that the energy consumption for AI would be the size of Austria by 2025.
Yep.
Is there something special about AI which makes it so computationally intensive, and what would you see the opportunities there as?
So there are elements of the way that AI works, which is a lot of the success and power of AI has come from massive data and massive compute. As I said, why it's popular again. So there are things that are specific to AI because that's the way it functions. And I think that can't continue to scale. I think something has to break in that regard. And there are researchers who will look at learning and generalizing from small data sets or less compute intensive methods. And in fact, the latest blog I wrote, so I said I wrote a blog on AI-powered universities, that is actually I published this week, was about sustainability and AI and about some of the choices that you can need to be made in order to make environmentally sensitive decisions about the use of AI. So I think there are genuinely some things that are relevant, specific to AI. Some of it comes from just running big data centers, which is not all AI, but I think there are generally some bits. And I can point you at the blog. It's an OECD AI policy blog just published.
Thank you. Oh, fine. And then we'll let you go.
We'll let these folk go.
Himanshu Kaul, I'm in engineering at Leicester. First of all, thanks for that very inspiring and insightful talk. I wondered when researchers or lecturers are trying to do something good for humanity, or students like writing an application for the next clinical trial, they have to go through ethics approval, GDPR compliance. And I wondered what sort of regulatory structures and systems need to be innovated to deliver the vision of AI-powered universities.
I think that's a really interesting question, and I'm not sure I have a really good answer to it. I think some of the regulations that will come in through AI as it pervades society. Let me answer at a sort of bigger level than university research. I think some of the guidelines and some of the regulations that we already have in place are fine and appropriate for AI-powered devices. So think about medical devices, right? So we've got quite an elaborate approval bodies and structures for approving new medical devices. And I think that's probably fine and adequate for AI-powered medical devices as well. I think the bit that's difficult to figure out is where there is something new and specific to AI. And sort of, I used to be on the UK's AI Council, and we used to worry about sort of regulator capacity in order to be able to figure out what regulation was appropriate. We used to worry about whether we were regulating too early and would stifle innovation by over-regulating, or the opposite of under-regulating and having slightly of a Wild West. So I think it's really a really interesting area and topic to explore, and I don't think I have great insights into it at this time, but it's something we have to get right. The UK government is trying to position us as a sort of smart regulator country, with being outside the EU, being able to diverge from Europeans. Finally there might be a benefit here. So having some smart regulation and wanting to be able to be that sort of test bed for modern technologies.
Thank you very much, and thank you to everybody who has asked questions. I think you can see by the audience and the hands that are up, this topic is both inspiring and it provokes a lot of interest and a lot of questions. So I'd like to say thank you very much for your lecture. And for taking all those questions. And I hope that the audience today found that discussion both inspiring and informative as well. I think stay connected as a community as we continue to explore the exciting potential of AI and other innovations that will really shape the future of our universities. So I'm going to close the lecture now. Say thank you for a wonderful evening. For those guests attending at the dinner, if we could just meet outside the lecture theatre, and we'll be going as a group. And to the rest of you, safe travels home, and thank you for coming, and hope to see you again in the future. Thank you.